Determining differentiability of piecewise functions. A piecewise function f of x is differentiable at x equal to c if the derivative from the left at x equal to c equals to derivative from the right at x equal to c. Derivative from the left is limit x approaches c from the left f of x minus f of c over x minus c, provided the limit exists. Derivative from the right, limit x approaches c from the right, f of x minus f of c over x minus c, provided the limit exists. Example 1. Determine whether the function is differentiable at x equal to 3. So f of x equal to x squared plus 1 for x less than or equal to 3, f of x equal to 4x minus 2 for x bigger than 3. Let's check for continuity at x equal to 3. So let's take the limit from the left. X approaches 3 from the left of f of x. As x approaches 3 from the left means x is less than 3. Therefore we choose f of x equals to first equation x squared plus 1. So this limit becomes a limit x approaches 3 from the left, x squared plus 1. Now x squared plus 1 is a closed form function, so therefore we just do direct substitution, substitute x equal to 3. So this becomes 3 squared plus 1, 9 plus 1 equals to 10. So the left limit is 10. Now we find the right limit. Limit of f of x as x approaches 3 from the right. Now x approaches 3 from the right means x is bigger than 3, and that condition is this one. So we use f of x equals to 4x minus 2. So we replace f of x in this limit 4x minus 2. Now again 4x minus 2 is a closed form, so we do direct substitution, x equal to 3. So it becomes 4 times 3 minus 2, which is 12 minus 2 is 10. As you can see, left limit is 10, right limit is also 10. So therefore f of x is continuous at x equal to 3. Since f of x is continuous at x equal to 3, we can find the derivative from the left at x equal to 3. Let's start with the formula. The derivative from the left at c is limit x approaches c from the left, f of x minus f of c over x minus c. Now substitute c equal to 3. So the left derivative from the left at 3 will be then limit x approaches 3 from the left, f of x minus f of 3 over x minus 3. Now x approaches 3 from the left means x less than 3. So we can choose f of x equal to x squared plus 1. And then substitute x equal to 3. And then it becomes f of 3 equal to 3 squared plus 1, which is 9 plus 1, 10. So now we substitute f of x equal to x squared plus 1 and f of 3 equal to 10 in the formula for the first derivative from the left at 3. So this becomes limit x approaches 3 from the left, x squared plus 1 minus 10 over x minus 3. This simplifies to x squared minus 9 over x minus 3. So now we factor x squared minus 9, which will be x minus 3x plus 3. We can cancel out x minus 3 and we're left with limit x approaches 3 from the left of x plus 3. X plus 3 is closed, so we substitute 3 with the axis to become 3 plus 3 is 6. So therefore, the first derivative from the left at 3 is 6. So next we're going to find the derivative from the right at x equal to 3. For f of x equal to x squared plus 1 when x is less than or equal to 3, and f of x equal to 4x minus 2 when x is bigger than 3. Now the derivative from the right is given by this formula, limit x approaches 3 of f of x minus f of c or x minus c. And c is 3, this one. So now I substitute c is 3 in the formula, it becomes limit x approaches 3 on the right, f of x minus f of 3 over x minus c. So now we have to decide what is f of x and what is f of 3. Well, since x approaches 3 from the right, it means x is bigger than 3, which is this. So therefore we use f of x equal to 4x minus 2. Now to find f of 3, since x is equal to 3 here and that's 3 equals, so therefore we use the first function, f of x equal to x squared plus 1. So we substitute 3 in this equation, so it gives the f of 3 equals 3 squared plus 1 equal to 9 plus 1 equals to 10. So now derivative from the right is limit x approaches 3 from the right, f of x minus f of 3 over x minus 3. So we substitute f of x equals 4x minus 2 and f of 3 equals to 10, and this becomes limit x approaches 3 from the right, 4x minus 2 minus 10 over x minus 3. Now minus 2 and minus 10 make it 12, so we have a limit x approaches 3 from the right, 4x minus 12 over x minus 3. Looks like we can factor 4 out and we get limit x approaches 3 from the right, 4 times x minus 3 over x minus 3. Now x minus 3 is cancelled out, so we're going to have a limit of 4 as x approaches 3. Since 4 is constant, so limit of constant is constant, so therefore the derivative from the right is 4. Derivative from the left is 6 and derivative from the right is 4. Derivative from the left is not equal to derivative from the right. So the derivative at x equal to 3 does not exist. So the answer is f of x is not differentiable at x equal to 3. Example 2. Consider this function f of x equal to square root of 4 minus x squared. Find the derivative from the left at x equal to 2. So the derivative from the left at x equal to 2 is limit x approaches 2 from the left, f of x minus f of 2 over x minus 2. So now substitute f of 2, which is square root of 4 minus 2 squared equal to 0. And f of x equal to square root of 4 minus x squared. So this becomes limit x approaches 2 from the left, the square root of 4 minus x squared minus 0 over x minus 2. Now we multiply and divide by 4 minus x squared square root. So we have limit x approaches 2 from the left, the square root of 4 minus x squared over x minus 2 times square root of 4 minus x squared square root of 4 minus x squared. Now we can multiply these two, so this becomes square root of square root of 4 minus x squared over x minus 2 times square root of 4 minus x squared. Square root of 4 minus x squared is 4 minus x squared. Now we rewrite 4 minus x squared as minus x squared plus 4. We factor out negative 1, you have x squared minus 4. The factors of x squared minus 4 are x minus 2x plus 2. We can cancel at x minus 2's. So we have a limit x approaches 2 from the left minus x plus 2 over square root of 4 minus x squared. So now we substitute x equal to 2. So you have a negative 2 plus 2 over square root of 4 minus 4, 2 squared. So that will be negative 4 over 4 minus 4 square root minus 4 over square root of 0. Square root of 0 is 0. So the negative 4 over 0 is negative infinity. So the limit does not exist. The answer is derivative from the left is d and e. So now we consider the function f of x equal to square root of 4 minus x squared. Now find the derivative from the right at x equal to 2. Now for x greater than 2, square root of 4 minus x squared is undefined. So therefore the derivative from the right is d and e. Now the question is f differentiable at x equal to, I mean this f. The answer is no, because derivative from the left and from the right do not exist. So let's see example 3. Consider the function f of x equal to absolute value of x plus 2. So let's find the derivative from the left at x equal to negative 2. Now start with f of x equal to absolute value of x plus 2, substitute x equal to negative 2. So f of negative 2 is 0. So now we write derivative from the left, that we limit x approaches negative 2 from the left, f of x minus f of negative 2 over x minus minus 2. Now as x approaches negative 2 from the left means x is less than negative 2. And therefore f of x equal to absolute value of x equal to negative of x plus 2 for x less than negative 2. Because now we substitute f of x equal to negative x plus 2 and f of negative 2 is 0. So limit x approaches negative 2 from the left, f of x minus f of negative 2 over x plus 2. So replacing f of x with this one and f of negative 2 with this one, 0. So we have a negative x plus 2 minus 0 over x plus 2. Now if you simplify this top, you get negative x plus 2. Now x plus 2 and x cancel out, and you're left with negative 1. So now we have a limit x approaches negative 2 from the left of negative 1. Now negative 1 is constant, and limit of constant is constant, so difference is negative 1. So now let's see, for f of x equal absolute value of x plus 2, let's find the derivative from the right at x equal to negative 2. So we start with f of x equal to f of absolute value of x plus 2, substitute x equal to negative 2. So we get f of negative 2 equals to negative 2 plus 2 absolute value, which is equal to absolute value of 0, which is 0. Now we write the derivative from the right. Limit x approaches negative 2 from the right, f of x minus f of negative 2 over x minus minus 2. Now as x approaches negative from the right, it means x is bigger than negative 2, and f of x is absolute value of x equal to x plus 2 for x negative 2, greater than negative 2. So we substitute f of x equal to x plus 2 and f of negative 2 equals 0 in the right derivative, this one, and then f of x becomes x plus 2, f of negative 2 is 0. So now this becomes simplifies to x plus 2 cancels out, we got 1. Now the limit of 1 as x approaches negative 2 from the right is 1, because 1 is constant and limit of constant is constant. So is f of x equal to absolute value of x plus 2 differentiable at x equal to negative 2? Well, since the derivative from the left is negative 1 and derivative from the right is 1, so the derivative from the left is not equal to derivative from the right. So we can say f of x is non-differentiable at x equal to negative